SMO Singapore Mathematical Olympiad 2020 senior section first round. We want to solve problems. We try to solve with logical ways. If you had question about anything, any solution, or also if you had question about problems of other exams, feel free to send message to my WhatsApp number here and in the description. Problem number one, let b be a positive integer if the minimum possible value of the quadratic function 5x squared plus bx plus 506 is 6. Find the value of b. Okay, so we can write this term as 5. We factor from 5, it will be x squared plus bx over 5 plus 506 over 5, and then you can say, okay, it's 5x plus bx over 10 squared, and x plus b over 10 squared, then you have b squared over 100, right, minus b squared over 100 plus 506 over 5. And you know the maximum, it says what? Minimum happens when it is 0. Then we have negative b squared over 20 plus 506 equals 6. So then we conclude what? B squared over 20 equals 500. So b squared equals 10,000. And so absolute value of b is 100. The problem says let b be a positive integer, so b equals 100. So the answer is B. SMO 2020 senior section first round problem number 2. Which of the following is equal to this? We consider this term, let me write with blue, this term equals to x. If I consider x squared, then I have 5 plus root 3 plus 5 minus root 3 plus 2 times this, which will be 25 minus 3. And it will be what? They will be cancelled. It will be 10 plus 2 root 22. So x is this. We know x is positive. So x equals root 10 plus 2 root 22. So the answer is D. SMO 2020 senior section first round problem number 3. Simplify this term. So let me tell you one important thing, that log a to the power of m, b to the power of n, a, b are positive. It will be m over n. Let me write on right side. It will be m over n log a in base b. Also log a b log b c equals log a in base c. If you have any problem or want to learn all the ideas of logarithm, also other things, as I said, feel free to send message to my WhatsApp number in the description. Now let's consider this one. Log 8 is 2 to the power of 3. It will be 1 over 3 log, let me consider it is a. So a equals 1 over 3 log 5 in base 2 log 3 in base 5 plus 1 is 3 squared, 5 squared, so 2 over 2 will be 1 log 3 base 5 and plus it's 3 cubed, 5 cubed, again 3 over 3 log 3 in base 5. So it will be 3 times this, 3 and 1 over 3 will be cancelled, so it will be log 5 in base 2 times log 3 in base 5. Like here, 5 will be cancelled, so the answer will be log 3 in base 2. So the answer is A. SMO 2020 senior section first round problem number 4. Let A equals this, B is this, C this. Which of the following is true? When you have these powers, one useful idea also in other SMO problems is to reach powers that are equal and then consider the bases. Okay, so here if you consider 1 over 505, it will be 1 over 5 times 101. 1 over 303, it's 1 over 3 times 101. 1 over 202, it's 1 over 2 times 101. So we can say it's if we multiply, so let's consider these three numbers. So we say, okay, 50 for 1 over 5. This number, the first one, b is 10 to the power of 1 over 3. 101. C is 6 power of 1 over 2. 101. So we should consider these three cases, the bases. Now we raise all of them to the power of 2. 3 LCM is 30. So we want to consider them. We raise the power of 30. Power of 30. So it will be what? The first number will be 50 to the power of 6. The next one 10 to the power of 10. The last one 6 to the power of 15. And now we should consider these numbers. So at first let's focus on these two numbers. 56, and we want to see 10 to the power of 10. We say, okay, it will be 5 to the power of 6, 10 to the power of 4. It's what? It's 10,000, and 5 to the power of 6 is 6 to 5. 5 to the power of 4 times 5 times 5. 5 times this is around 3. Okay, so it is greater than this one, greater than 5 times 600, 3,000. So 15,000. So we can say this number is greater than 15,000, so it's greater than 10,000. So if I consider this one A prime, this one B prime, this one C prime, here I proved that A prime is greater than B prime. Now here I consider, for example, 10 to the power of 10 and 6 to the power of 15, then it will be 5 to the power of 10, and it will be 2 to the power of 5 times 3 to the power of 15. Now, if we consider 2, 3, it will be 6 to the power of 5, and then times 3 to the power of 10. If you consider 6, we should check, is 3 to the power of 10? It is greater than 9 to the power of 5. So 9 to the power of 5 times 6 to the power of 5, we see that it is greater than, you can say each of them, it's greater than 5 to the 5, also it's greater than 5 to the power of 5, so it's greater than 5 to the power of 10. So we see it's greater than this, so it is greater than this. Now we conclude what C prime also is greater than B prime, so now we should check A prime and C prime. It's 50 to the power of 6, 6 to the power of 15. So if we cancel, it's 2 to the power of 6 and 5 to the power of 12 because it's 5 squared. 2 to the power of 6 will be cancelled here by 2 to the power of 9, 3 to the power of 15. Now here when we want to consider the power, you can say it's 5, 4, power of 3, it's 2 cubed, 3 to 5 to the power of 3. Now we should check these two numbers. 5 to the power of 4 is 625, and this is 8. 3 to the power of 5 is 243. It will be greater than 1000. So here we can say it's greater than this. So 6 to the power of 15 is greater than 50 to the power of 6. So C prime is greater than A prime greater than B prime. So we can say similarly C greater than A greater than B, C greater than A greater than B. So C is the answer. SMO 2020 senior section first round, problem number 5. Let P, Q, R are these things where X is between 0 and pi over 2. Which of the following is true? So we know because X is between 0 and pi over 2. So sine X is between 0 and 1. So because base here is 10 and sine X is less than 1, if it is 1, log will be 0. And 10 to the power of 0 is 1. 10 to the power of negative 1 is less than 1. So P is less than 0. Q is positive, but Q, we can say Q is positive, But q is less than 1 because the number between 0 and 1 raised to the power of 10 is less than 1. And r is 10 to the power of something greater than 0. 10 to the power of 0 is 1. 10 to the power of something positive will be greater than 1. So r is greater than 1. So r is greater than q, greater than p. So which of them are greater than q, greater than p part? So answer is A. SMO 2020 senior section first round problem number 6. Find the minimum possible value of this where x is any real number. Important x's for this, we want to imagine diagram, but also after solving some problems you can imagine. In this problem we draw it and you can see how we can easily solve these kinds of problem. These kinds of problem usually we see in SMO. So 10 is important, 20 is important, 30 is important. So if x is less than 10, it will be 10 minus x. Let me call this one, for example, y. So I want to see y will be what? Y will be 10 minus x minus 20 minus x plus 30 minus x. So we have this and this will be cancelled, negative, negative, positive. 30 plus 10, 40 minus 20, 20. 20 minus x. If x is greater than equal 10 less than 20, then y is x minus 10 minus 20 minus x plus 30 minus x. So they will be cancelled and we have 30 minus 20 minus 10, 0 minus minus x plus x. If x is greater than equal 20 less than 30, so y equals x minus 10 minus x minus 20 plus 30 minus x. So this x, negative x and x will be cancelled. 30 plus 20, 50 minus 10, 40. 40 minus x. And the last part, if x is greater than equal 30, so y equals x minus 10 minus x minus 20 plus x minus 30. So here they will be cancelled. It will be x plus 20 minus 10 is 10. 10 minus 30 is minus 20. So if we connect, if we want to draw this point for 10, it will be 10. Let me show you approximately. Less than 10, here it will be 10 and it will be something like this. And okay, so it is 10, it is 10. After 10, it will be x and until 20. So in 20, it will be something like this. And here we will see 20 for 20. And for 30, we can say what? Y is 40 minus x. Again, it will be this. Then we have 10 again. And then after this, it will be x minus 20. It will be this. So the minimum possible value of this function equals these 2 points equals 10. SMO 2020 senior section first round problem number 7. Parallelogram ABCD has sides AB 39. Let me draw it. So side AB is 39. So also CD will be 39 because it's parallelogram. BC 25. So also AD is 25. Find the length of AC, this diagonal, if diagonal BD is 34. So we know what? We know BD squared equals, let me write this xy, this is x, it is y. BD squared equals x squared plus y squared minus, let me call this one alpha, minus 2xy cos alpha. And this is alpha, if you consider it will be also alpha because they are parallel. So you can say it is 180 minus alpha. we can say AC squared equals x squared plus y squared minus 2xy cos 180 minus alpha. Cos 180 minus alpha is negative cos alpha, so it will be 2xy cos alpha. If we add up these two things, we will reach an important thing in parallelograms. BD squared, memorize this. There are, as I said before, there are around 50 important ideas, 50 important formulas in parallelogram and also other geometric things, median, angle, bisectors, perpendicular. If you want to know them, as I said, feel free to send message to my WhatsApp number here and also in the description. So let's solve it. BD squared. This idea also was useful in AMY for USA. BD squared plus AC squared equals 2x squared plus y squared. We know BD squared is 34 squared plus AC squared 2 times x squared, which is 25 squared plus 39 squared. So let's calculate. It will be 62539 times 39 will be 9 times 9, 81. We have 8. 9 times 3, 27 plus 8, 35. 3 times 9, 27, 2. 3 times 3, 9 plus 2 is 11. 1, 2, 3, 1, 4, 5. 1, 15, 21. And 34 squared equals what? 4 times 4, 16. We have 1. It's 13. 3 times 4, 12. 1. It will be 10. And it will be 6, 5, 1, 1. So AC squared equals, if we add up these two numbers, it will be 6. 2 plus 2, 4. 6 plus 5, 11. And we have 2. 2 times this, 2 times 6, 12. 1. 2 times 4, 8, 9. 2 times 1, 2. 4 minus 34 squared, which is this. And we can say 12 minus 6 equals 6. 8 minus 5, 3. 2 minus 1, 1. And 4 minus 1, 3. Now we want to use a square root of this number. So AC equals root 31. So finding the root is so much important in SMO problem. If you want to know the algorithm, we can send message to my WhatsApp number in the description. But here also, if you pay attention, you can learn. From right side, you consider 2 by 2, then 31. 5 times 5 is 25. Then you have 6, 3, 6, then twice 5, 10, 100. What? You should place same number. If you place 6, 6, 6, 36, 3, 6, it will be 0, so 56. So the answer AC equals 56. SMO 2020 senior section first round problem number 8. Suppose sine 45 minus x equals negative 1/3, where x is greater than 45 degree, less than 90 degree. Find 6 sine x minus root 2 squared. Okay, so here we consider this is alpha, so 45 minus x equals alpha. Then we can say, okay, x is between 90 and this, so negative x is greater than negative 90, less than negative 45. And then if you add 45 to three sides, it will be negative 45 and less than 0, so alpha is between this. Now, sine alpha, if I want to show on the unit circle, you can imagine. But if you've not solved many problems yet, so let me show it here. You see that for this point, sine is negative, cos alpha is in this area. In this area, alpha sine is, and it is open. In this interval, sine is negative, cos is positive. So sine alpha is negative 1/3, and cos alpha is negative 1/3. And then you should consider it's 1/9. It will be 8/9, and because cos is positive, it will be root 8/3. Now you use sine squared plus cos squared equals 1. So here we want what? 6 sine x. X is what? X will be 45 minus alpha. So the problem says find 6 times sine 45 minus alpha minus root 2 all squared. So sine, if I consider this sine 45, you can factor from root 2 over 2. It will be sine 45 times cos negative alpha, which will be cos alpha, plus cos 45 times sine negative alpha will be negative sine alpha, and here it will be negative root 2 squared. So here it will be 3, and we can factor from root 2, it will be 2 times 3 times this, so it will be 9 cos alpha minus sine alpha squared plus 2 minus, plus 1 here, you write minus 2 root 2, 3, which will be 6 cos alpha minus sine alpha. And then we say, okay, it will be what? It will be 9 cos squared plus sine squared. It will be 9 plus 1, 10. And then negative 2, 9, 18 cos alpha sine alpha. And here you write minus 6 cos alpha plus 6 sine alpha. And cos alpha times sine alpha will be negative root 8 over 9. And negative 6 cos alpha will be negative 2 root 8. 6 sine alpha will be negative 2. Now, if we consider 18 times this, it will be 2 plus 2 root 8 here, negative 2 root 8. So they will be cancelled. Let me write the rest of that with black. Here and here will be cancelled. It will be 2. 10 minus 2, 2 times 8 equals 16. So the answer is 16. SMO 2020 senior section first round, problem number 9. If 8 cos x minus 8 sin x equals 3, find the value of 55 tangent x plus 55 over tangent x. One useful and basic idea is replace, but first let's factor from 55. Let me write with blue. Tangent x, write it sine x over cos x. It will be plus cos x over sine x. If you use common denominator, it will be 55, 1 over cos x sine x. And now here, if I raise both sides to the power of 2, it will be 64 cos x minus sine x squared. It will be cos squared plus sine squared 1 minus 2 sine x cos x, which will be 9. So here we say, okay, it's 61 minus 2 sine x cos x is 9 over 64. So 2 sine x cos x is 1 minus 9 over 64. So it will be 64 minus 9, which will be 55. And then we reach that sine x cos x equals 55 over 128. Now we write here 55 reciprocal of that, 1 to 8 over 50. So if we cancel 55 and 55 here, the answer is equal to 128. SMO 2020 senior section first round, problem number 10. Find the number of ordered pairs x, y, where x and y are integers such that x squared plus y squared minus 20x minus 14y plus 140 is less than 0. Okay, so if we write as perfect square, it will be x minus 10 squared plus y minus 7 squared. It's plus 100, so we write minus 100 plus 49 minus 49 plus 140 is less than 0. If we consider this, it will be negative 9. So x minus 10 squared plus y minus 7 squared is less than 9. So it can be 0 or 1 squared or 2 squared, 4. If it is 3 squared, then 9 plus something non-negative, it's not less than 9. So it's 0, 1, 4. The cases we should check 0, 0, 0, 1, 0, 4. 1 0 1 1 1 4 4 0 4 1 4 4. So the first one, x minus 10. At first, let's consider the cases for these. Let me find this. If x minus 10 is 0, x is 10. For this one, x is, let's check. X will be, x minus 10 is 1 or negative 1. So it's 10 plus 1. It's 11 or 10 minus 9, which is 9. For this one, x minus 10 is 4 or negative 4. It will be 10 plus 4, 14, or 10 minus 4, 6. For this one, y is 7. For this one, y is 7 plus minus 1, which is 8 or 6. For this case, y is 7 plus minus 4, which is, sorry, here it is 4, so it will be 2. So x minus 10 is, let me write with pink again, it is plus minus 2. 10 plus 2, 12, 10 minus 2, 8. This one, it's 8 or 6, it's y. Y minus 7 is plus minus 2. 7 plus 2, 9. 7 minus 2 is 5. So here x can have 1, 2, 3, 4, 5 cases. Y also has 5 cases. Each of these 5 cases of x times each of them will be answer. So the answer equals 20. SMO 2020 senior section first round, problem number 11. The figure below shows a right angle triangle. Okay, so let me draw by blue. Okay, such that BAC is 90, ABC is 30. Let me minimize. It's 30. AB is 48. AB is 48. And let P be a point on side AB such that CP is angle bisector of this. So we know it is 60. So it should be 30, 30. Try to apply the things on the figure. And Q be a point on side BC such that AQ is perpendicular to CP. Okay, so it is 60. It is 60. Determine the length of PQ. Okay, so we know it is 48. It is 60. So we can find length of triangle ABC. Why? Because BCA. A root 3 over 2 because it is opposite 60 degree equals 48. So A equals what? A equals 96 over root 3, and you can say, okay, 96 root 3 over 3, which if we simplify, it will be 32 root 3. So this side will be 32 root 3. It is 30, it is half of hypotenuse because sine 30 is 1/2. So it will be 16 root 3. Now we know it is 16 root 3. Okay, so we want to find PQ. If we can find this length in this triangle with cos rule, we can solve the problem. It is 16 root 3, so it is 16 root 3 because it is an isosceles triangle. All BC is 32 root 3. It is 16 root 3, so it is also 16 root 3. It is angle bisector. We know an important formula. As I said, there are around 50 important formulas, one of them for angle bisector. If you want to know all of them, or if you have question about anything, feel free to send message to my WhatsApp number in the description and comment. So when we have it is angle bisector, these two angles are equal. DC is A is BC. A, it is B, it is C. It is AB over B plus C. BD is AC over B plus C. You should memorize this. Now BP here is what? Here is CA over A plus B. CA is what? C is 48. A is what? 32 root 3 over A plus B is 32 plus 16, 48 root 3. So we cancel, also we cancel this, and it will be what? 32. So this side will be 32. Now we say, okay, let's use, let me maximize the pen. Let's use cosine rule in triangle PQ. be to find PQ. PQ squared is 32 squared plus 16 root 3 squared minus 2 times 16 root 3 times 32 times cos 30. Cos 30 is what? Is root 3 over 2. Now, let's see, we can factor from what is 32 squared plus 16 squared times 3 minus, you can cancel these two, minus 16 times 32 times 3. So we can factor from 16, 32, we can factor from 16 squared. It will be 4 plus 3 minus 6. So it will be 4 plus 3, 7, minus 6, 1. So it will be 16 squared. So PQ equals 16. And the problem wants PQ, so the answer is equal to 16. SMO 2020 senior section first round, problem number 12. In the figure below, the point O is the center of the circle. AD and BC, AD, BC intersect at E, and AEB is 70 degree. AEB, let me minimize. AEB is 70 degree. AOB, AOB is 62 degree. Find the angle OCD. OCD, okay, this is alpha. The problem wants alpha. If we, let me draw with green, if we extend this, let's see what things we have. Okay, here we know it's 62 degrees, so it is 62, yes, central angle. It is interior angle. Interior angle is sum of this arc plus this arc over 2. So if I consider this is x, I say 62 plus x over 2 is 70, so 62 plus x is 2 times 70, 140. So x equals 140 minus 62. 110 minus 2, 8. It will be 3, 13 minus 6, 7. And 0 minus 0, 0. So it's 78, this angle. 78 degree. Now if I, because it is diameter, you can draw this. You know it is 90 because it is diameter, and this angle is what? 78. 78 is inscribed angle. So it is 78 over 2, which will be 39. So alpha will be 90 minus 39. 90 minus 39 will be 51. So the answer of the problem, because the problem wants alpha, equals 55 degree. SMO 2020 senior section first round, problem number 13. Find the value of 4 cos 43 over sine 73 minus 12 sine 43 over root 3 sine 253. Now, if we want to solve this problem, we say, okay, we know sine alpha plus 80 equals negative sine alpha. So we can say, let me maximize, we can say sine 2530 equals negative sine. This minus 180, which will be 73. Now, if we replace here, then both denominators have sine 73. So it will be 4 cos 43. It will be negative, 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 positive, plus 12 on 12, yes, sine 43 over root 3. Now, we factor from 8 here. It will be 8 sine 73. Here, 1 over 2 cos 43. And if we consider this number, 12 over root 3, you can say, okay, it's 4 times 3. 3 is root 3. Root 3. Okay, so why? Because 12 is 4 times 3. It is 4 times root 3, root 3. If you divide it by root 3, then we have this. If we factor from 8, then we have root 3 over 2 sine 43. So this one is sine 30. This one is cos 30. Now we say what? We say, okay, sine, cos, cos, sine. It will be sine sum of them, sine 73. If we cancel, then if I write this, it will be 8 over sine 73 times this part sine 73. We cancel these two terms, so the answer is equal to 8. Senior section, first round SMO 2020, problem number 14. If x squared over 5 plus y squared over 7 equals 1, find the largest possible value of x plus y squared. Again, for this problem, we use the famous theorem, Lagrange multiplier. We consider g equals x squared over 5 plus y squared over 7 minus 1, which equals 0. And then we say, okay, f is x plus y squared. We solve this idea in many problems of SMO. If you want to learn this or other things, as I said, feel free to send message to my WhatsApp number in the description and also in the comments. We define L equals f minus lambda g equals x plus y squared minus lambda x squared over 5 minus lambda y squared over 7 plus lambda. Now we differentiate from L and x. Okay, it will be what? It will be 2 times x plus y minus 2 lambda x over 5. It equals 0. If we differentiate from L in terms of y, it will be 2 times x plus y minus 2 lambda y over 7 equals 0. Now, here we say, okay, if we divide both sides by 2, then lambda will be what? Lambda, you say x plus y equals lambda x over 5. So lambda equals 5x plus y over x. Here, if we consider this one, again, you divide both sides by 2 and you say x plus y. Take this term to right hand side, it will be lambda y over 7. So lambda equals 7 over x plus y over what? Over y. Now, here we should consider the case that maybe x equals 0, the denominator equals 0. So, case 1. If x equals 0 here, so you can conclude easily it is 0, 0. So y is also equals to 0. So in this case, the problem says x and y can be any real number. So in this case, f equals 0. Similarly, if y equals 0, then you can say x equals 0, then f equals 0. So case 2, we write with a loss of generality. If one of them equals 0, we have this. Now we consider x is not 0 and y is not 0, so we have lambda here. So we can conclude 5 times x plus y over x equals 7 times x plus y over y. Both of them equals lambda. Now we say, okay, in this case, we have let me write 5 times y times x plus y equals 7 times x plus y. In this case, case 2, 1. If x plus y is 0, then we can say f equals x plus y squared, f equals 0. In case 2, you say, okay, it is not 0, x plus y is not 0, so you can cancel it from both sides, so 5y equals 7x. Now we had an equation here. Let me copy this one. And we find x and y. So here, you say, okay, y is what? Y is 7x over 5. Now we say, okay, x squared over 5 plus 7x, it will be 49x squared over 25 over 7 equals 1. You cancel, it will be 7. And then you say, okay, it's 5x squared, common denominator 25 plus 7x squared over 25 equals 1. So we conclude 12x squared equals 25 if we cross multiply. And then you say, okay, x squared, x is plus minus 5 over root 12. Okay, and also we conclude y is what? Is 7 over 5 times this it will be plus minus 7 over root 12. And the problem says what f is x plus y squared. So if we want to x plus y squared, if we want to maximize this, we should consider same sign without loss of generality. For example, plus plus here, so it will be 12 root maximum. 12 over, this one is root 12. 12 over root 12 squared. It will be root 12 squared, which equals 12. So the answer, the maximum, in previous case we found maximum for f 0, here 12. Because the problem wants maximum, we compare them, and the answer is equal to. Find the coefficient of x6 in the expansion of 1 plus x plus 2x squared to the power of 7. Okay, we want 7. Suppose we select, for example, alpha here, beta here, so 7 minus that. Alpha plus beta is at most 7. I want to create what? x6. So I know what? I know 2 beta plus alpha should be equal to 6. So beta, maximum beta can be 3. Alpha will be 0. It will be 2. It will be 2. It will be 1. It will be 4. Here it can be 0 and it will be 6. Now let's consider case by case. Beta is 3, so you say 7, choose 3 and 2 cubed. Alpha is 0, and because beta is 3, it is 0, so we should select, for example, suppose here it will be gamma equals 3 plus 0 plus 4 should be 7. So you say, okay, we don't select this, and here it will be 4, choose 4, which is 1. You can also ignore that. Beta is 2. So you can say 7, choose 2, 2 squared. Alpha equals what? Alpha equals 2. You select 2, 2 here, 3. So it will be 7. Now, if I move it, it will be what? 2 squared. Then you have 5. 5, choose 2, 3, choose 3. The next one. It is 1, it is 4. So 1, 4, 5, it will be 2. It will be 7, choose 1 for this, times 2, times. What is left? 6. 6, choose 4, and then 2, choose 2. The last part. 0 here. So we have what? We have 0 in this part, 6 in this part, 7, it will be 1. So 7, choose 0, we don't select, or you can ignore it if you want. Then you say, okay, 7, choose 6, finished. If you don't want to write 5, choose 5. You can only write the things that are not equal to 1. You can only write things that are not equal to 1. Okay, so if I calculate, the first one will be 7, 6, 5 over 3 factorial 6 will be cancelled. Times 8, it will be 40 to 80. This one will be 21 times 4 times 10. It will be 840. This one will be 6 choose 2, 6, 5 over 2, 15 times 2, 30. 7 times 30, 210. It will be 7. Now, if we add up all these numbers, 0, 0, 0, 7. 8, 4, 12. 12 plus 1, 13. We have 1. 2 plus 8, 10. 10 plus 2, 12 plus 1, 13. So the coefficient of this and the answer is equal to 1337. SMO 2020 senior section first round problem number 16. Suppose this term equals 7. Find the value of absolute value of x plus y plus z. For this term, and this term. This term is a little complicated inside square root. Can we write it as square? So you say, okay, we have x minus 11. And if we write plus 2 times this 14, 7 squared. If I calculate this, it will be x minus 11. This is squared plus 49 plus 14 x minus 11. And 49 minus 11 will be 38. And we see this exactly equal to this. So we say it's 3x minus y squared plus absolute value of this term, and we know it is positive because it is square root, and we know x must be at least 11 plus 7 plus z minus plus x minus y absolute value equals 7. So if we cancel these two things here, it will be 0 if we subtract 7 from both sides. So this thing, it is at least 0, it is at least 0 non-negative. When we have some non-negative terms, it is famous idea. If you want to know this famous idea in algebra and all other lessons, as I said, feel free to send message to my WhatsApp number in the description and also in the comments. And also subscribe to have next videos. So this one, turn on the bell. So they are all at least 0, so you can say okay, because the sum of them is 0, so each of them equals 0. So it is 0, x minus 11 is 0, z plus x minus y equals 0. So from first one, x equals 11, and if you replace here, y equals 33. If you replace here 11 minus 33, negative 22. So if you take it to right hand side, it will be 22. So absolute value of x plus y plus z equals, we can say 11 times 3 plus 1 plus 2. 3 plus 1 plus 2, which equals 6. So the answer is equal to 66. SMO 2020 senior section first round problem number 17. Suppose there are real numbers x, y, z satisfying the following equation: x plus y plus z equals 60, x, y minus z squared equals 900. Find the maximum possible value of absolute value of z. Here, like many SMO problems, we have constraint and we want to find minimum and maximum of something. In most of them, we've used Lagrange multiplier, and that's so much useful idea in SMO problems. If you want to know also other important and useful ideas, as I said, feel free to send message to my WhatsApp number in the description or comments. Now here, if you want to use the Lagrange multiplier, you say, okay, if I want to find absolute value of z, maximize this, so I say consider maximize or minimize this, because for example, if maximum z is 100, minimum is negative 200, so if we find minimum and maximum of z, then we can find absolute. Here, for example, absolute value of z, maximum is 200. So here we only want to consider the maximum or minimum of z. We want to find that. But here, in Lagrange multiplier that we've used so far, we have one constraint. Here we have two constraints. So we replace one variable in terms of other variable from one, and we calculate, for example, from first one, you say, okay, y equals 60 minus x minus z, and we replace in the second equation, and it will be x 60 minus x minus z squared equals 900. Now we have only one condition, and we can solve it by Lagrange multiplier. So f is this. Now let's define g. G is 60. Let's take all the things to right hand side. It will z squared plus 900 minus 60x plus x squared plus xz equals 0. And L is what? F minus lambda g. It will be z minus lambda z squared minus lambda 900 plus, let me write, plus 60 lambda x plus x minus x squared, because it's negative lambda g, negative x squared lambda, negative xz lambda. Now here, we differentiate from L in terms of x, for example, at first, it will be what? It will be 60 lambda minus 2x lambda minus z lambda equals 0. Differentiate in terms of z, and it will be 1 and minus 2 lambda z. Here we have minus x lambda, it is equal to 0. Now, from first one, you say, okay, lambda times 60 minus 2x minus z equals 0. From second one on, here you can say lambda is 0 or this one is 0, but if lambda is 0, then here we have contradictions. So lambda is not 0. Here we conclude 60 minus 2x minus z equals 0, so it's a good thing. here you say, okay, lambda equals, because here we don't reach any good thing in terms of lambda, so we should use this. 2x plus z, if you take these two things to right hand side, it will be 2x plus z equals 60. Now I can say, okay, z equals what? Z equals 60 minus 2x, and we can replace. Here our equation was this. We replace z with the things we've reached, and then we have one equation, one variable, we can find x. X times 60 minus x minus z is minus 60 plus 2x. Minus z squared will be 60 minus 2x squared equals 900. Now, here if we cancel 60 and 60, we have and these two things, it will be x squared minus 3600 plus 4x squared minus 240x equals 900. Now, x squared minus 4x squared is negative 3x squared plus 240x plus, you can take to the left hand side, minus 900 minus this will be negative 5400 equals 0. You can divide both sides by 3, and by negative 3 you can say x squared minus 80x plus 1500 equals 0. You can say it's x minus 30, x minus 50 equals 0. So we should check two answers, x equals 30 or x equals 50. If x equals 30, then we know what? We know z equals, here we found z equals 60 minus 2x. So z equals 60 minus 2x is 0. Here z equals 60 minus 2 times this, 60 minus 100. So it will be negative 40. So if for this case, absolute value is 0, here absolute value is 40. So maximum absolute value of z equals 40. So the answer is equal to 40. SMO 2020, senior section first round, problem number 18, find the sum of this term. So here we use what? We use log a in base b plus log c in base b equals log ac in base b. It's one formula, it's famous. There are around 8 important formulas in log that are useful in SMO. If you want to know them, as I said, feel free to send message to my WhatsApp number in the description and also comments. Now here we say, okay, we have log of some numbers plus them, so you can multiply all of them. So I should calculate what sine, at first, sine squared 1, it's p over 8 plus 1 minus sine p over 8 times the next one, sine squared 2p over 8 plus 1 minus sine 2p over 8, and if we consider all of them until 16, it will be sine squared 16 pi over 8 plus 1 minus sine 16 pi over 8. Now here we consider what? We should pay attention to these angles. Pi over 8 is what? Pi over 8, if you also want in degree, it will be what? It will be 180 over 8. It will be 45 over 2. And if I consider these angles and draw unit circle, let's see. Look, after solving some problems, you can imagine all these things. But if you've not solved many problems, you can show it's what? It's 0. It's what is pi? Pi over 2. So it is 4 pi over 8. It is what? It is 8 pi over 8. It is what? This angle? This angle is 12 pi over 8. And again, if you reach 0, you can say it is equal to 16 pi over 8. Now, if we consider the first one, let me write with pink. You should consider 4 points here. So 1 is pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi, 8 pi, and then it will be 9 pi over 8. It will be what? It's pi over 8 plus pi. And this one is this. Their difference is 180. This one is this. So they are our angles. This and this. So it will be what? Pi over 8. It will be what? 2 pi over 8. It will be 3 pi over 8. 5 pi over 8. 6 pi over 8. 7 pi over 8. For example, here 9 pi over 8. 10 pi over 8. 11 pi over 8. 12, 13, 14, and 15. So here you can see that we have pairs. For example, this one with this one. And because the difference is, we know sine alpha plus pi equals negative sine alpha. So you consider each pair and say, okay, if I multiply them, sine squared alpha plus 1 minus sine alpha times. So 1 alpha plus y, you consider this one and this one. We say it's negative sine alpha. When you raise to the power of 2, it will be sine squared alpha plus 1 plus sine alpha, because negative sine alpha will be this. So I consider these two terms, and then I consider these two together like this first. So it will be what? You can say it equals sine squared with the identity this squared minus this squared, sine squared alpha plus 1 minus sine squared alpha, it will be 1. So if you use this for each pair, we have 16 terms from 1 pi over 8 until 16 pi over 8. Product of all of them equals 1. And okay, so you can say product of all of these terms equals 1. So here you can say it equals log 1 in base 2, which equals 0. So the answer is equal to 0. SMO 2020 senior section first round, problem number 19. Let A, B be positive real numbers where A is greater than B. Suppose there exists a real number x such that log ax base 2 times log bx in base 2 plus 25 equals 0. Find the minimum possible value of A over B. Okay, it says suppose there exists a real number x. So if I consider this one, it will be log A in base 2 plus log. As I said also in previous problems, there are around 8 important formulas in log. And also, if you had any question about logs or other things, as I said, feel free to send message to my WhatsApp number in the description and also in the comments. So here it will be log x base 2 times the log b2 plus log x in base 2 plus 25 equals 0. It says there exists x. If we draw log, let me do this. Okay, if I want to show log, for example, x in base 2 and it is x, for 1 it will be 0 and it will be something like this. If I want to draw it, it will be this. So it can be any real numbers from negative infinity to positive infinity. So you say, okay, I consider this is y, so it means that there exists y here. So it will be what? Y squared plus y log a in base 2 plus log b in base 2 plus 25 equals 0. When the problem says there exists a real number x, it means there exists a real number y. So it is a quadratic function in terms of y. It means the discriminant is at least 0. So it will be what? Log a in base 2 plus log b in base 2 squared minus 4ac minus 100 is greater than equal 0. So you say, okay. Sorry. We forgot to consider log a in base 2 times log b in base 2 equals 0. So here it will be minus 4ac minus 100 minus 4 log a2 log b2 equals 0. Is at least 0. Now we say, okay, if I consider log a2 squared, let me write squared here, plus a log b2 squared plus 2 times this here, if you simplify, will be minus log a2 log b2 is greater than equal, take negative 100 to right hand side, it will be 100, and it will be log a in base 2 minus a log b2 squared greater than equal 100. So you should say, okay, log a minus log, the problem says which of them is greater, the problem a is greater than b. So because it is a strictly ascending function, so absolute value of this, it will be this, greater than 100. You change minus to division here, so it is this, raise 2 to the power of these two things, because 2 to the power of anything, let me show you, 2 to the power of x is this. It's 1 and it's ascending function, strictly ascending function. So because this is greater than this, 2 to the power of this, which will be ab, is when we consider square root, it will be 10 here, and ab is greater than equal 2 to the power of 10, which equals 1024. So the answer, it says, the problem says find minimum of possible value of a over b. So a over b, minimum of a over b equals 1020. SMO 2020 senior section first round, problem number 20. Okay, let's solve it here. The figure below shows a rectangle ABCD such that the diagonals AC is 20. Okay, let P be a point on side CD such that BP is perpendicular to diagonal AC. Okay, it is 90 degree. Find the area of rectangle ABCD if BP equals 15. So let's write angles. It is alpha. It is 90 minus alpha, so it is alpha. It is because it's 90. It's 90 minus alpha, so it is alpha. So we see many similar triangles. Here it's 20 hypotenuse of this triangle. Here is 15 hypotenuse of this triangle. So let's start from these two things. By two angles, easily you can say triangle ABC is similar to triangle BPC. And if you write all the things, AC over, okay, AC hypotenuse over BP equals AB is sine 90 minus alpha, 90 minus alpha, 90 minus alpha, BC equals BC alpha here, PC. AC is what? AC is 20, it's 20. BP is what? Is 15. If we simplify 5 here, 4, 3. So AB is 4x, we can say BC is 3x. Because AB over BC is 4 over 3. BC, we've considered BC is 3x, so we can calculate PC. PC is 9x, 3 cross multiply over 4. Now let's write this one here, 9x over 4. The problem wants area of ABCD, so if we find x, then we have AB and CB, then we multiply them. If we want to find x in this triangle PBC, if we use, let me write the rest of the solution with green. In BPC, if we use Pythagoras theorem, then we have 3x squared plus 9x over 4 squared equals 15 squared. You can divide both sides by 9, then you have x squared plus 3. Let me tell you, it's 9x squared, 81. So if you divide by 9, it will be 9x squared over 16 equals 5 squared, which is 25. So you can say, if you consider multiply both sides by 16, then 16x squared plus 9x squared, it will be 25x squared equals 16 times 5 squared. And if we consider square root, we can cancel 25 from both sides, and x will be 4. So x is 4. Now we can say, okay, this one will be 16, this one will be 12. So the answer is 12 times 16. It's 32, it's 16, so 192. So the answer is equal to 192. SMO 2020 senior section first round, problem number 21. Find the smallest positive integer that is greater than the following expression, root 7 plus root 5 to the power of 4. Okay, so let's consider, let me write with blue, let's consider it is A. So A is, you can say 7 plus 5 plus 2 root 35 to the power of 2. It will be 12 plus 2 root 35. You can take 2 outside. And it will be 2 squared. It will be 6 plus 35 squared. It will be 4 times 36 plus 35 plus 2 12 35. And it will be, if I add these two numbers, 171. Then we have 428 plus 48 root 35. Now, if I want to solve this number, so we should focus on this part because it is integer, it's obvious. So it will be 48, take it inside the square root 35. And then you can say, okay, it is 24 times 2 times is 70. So it will be, this. Now, if we multiply 48 by 168, 8 times 8, 64, 6. 8 times 6, 48 plus 6, 54, we have 5. 8 times 1 plus 5, 13. 4 times 8, 32, we have 3. 4 times 6, 24, 27, we have 2. And it will be 6, so it will be 4, 6, and 10, here 7, 8. So we should calculate square root of this number. And this algorithm is useful also in other SMO problems. You find square root of something. If you had problem with finding square root or other algorithms, ideas, as I said, feel free to send message to my WhatsApp number in the description and comments. So you consider from here, you say 2, 2, 4, 4, 0, 6. 2 times 2, 4. Then you say, okay, 49 is greater, 8. 8 times 8, 64. We have 6. 8 times 4, 32 plus 6, 38. It will be 2. It will be 2. Then 4, 0. You place 8 here. It will be 28 times 2, 56. You should place equal numbers here. It's around 500. 8 times that. 6 times 3 times 4 times that will be greater than this. So you should place 3 here. 3, 3, 9, 3, 6, 18. We have 1. And it will be 16. Okay, so it will be 283 point something. Now, if we want to find the smallest number that is greater than this, so the answer is 284 because of here, plus here 284. So the answer is equal to 8, 16, 5. So the answer of this problem equals 568. SMO 2020 senior section first round problem number 22. Find the number of non-congruent right-angled triangles such that the length of all their sides are integers and that the hypotenuse has a length of 65 centimeter. There is an important formula in number theory is if we have x squared plus y squared equals z squared and x and y are integers, you can, without loss of generality, you can consider they are non-negative because if you have x, for example, negative 2, you can consider 2 plus minus that. You can say there exist r and s that are integers such that GCD of r and s equals 1 and r is congruent to s plus 1 mod 2. It means what here? It means r and s have different parities. One of them even, one of them is odd. Then we can prove that x equals d r squared minus s squared, one of them. The other one you consider 2r sd. And z equals d r squared plus s squared. So this is an important theorem in number 3. If you want to the proof of this or also know the other important theorems in number 3 and all other topics, as I said, feel free to send message to my WhatsApp number in the description and comments. So find the number of non-congruent. Let's consider 65. So here x squared plus y squared, if I consider the triangle like this, it is z, it is 65. This one is x, this one is y. So you say x squared plus y squared equals z squared, which is 65 squared. Now you say, okay, z is d times r squared plus s squared. So let's at first try to see what r and s and d do we have. We know d divides z, so z is 65, so d can be 1 or 5, or without loss of generality, we can consider d is positive. Okay, because we consider only x, y that are positive, and r is greater 1, greater than equal s. So here we say, okay, it can be 1, 5, 13. Let's consider if d is 13, let's see what happens. Case 1, d is 13. So here we conclude what? We conclude, okay, x and d is 13, all of them are multiple of 13. So you consider x is x prime d, for example, y is, let me consider here x prime d, y prime d, z prime d. So here you say, okay, y prime d, and if we divide both sides of this by 13 squared, then we have x prime squared plus y prime squared equals 5 squared, which is 25. So here we know if we want to find the answer, the sides are positive. So one of them is 9, one of them is 16. Only we have this answer if you check all of them. So we found one answer that is 3, 4, and 5. So x prime, y prime, z prime. So x, y, z here equals 3 times 13, 4 times 13, and 5 times 13. So it is our first answer when d is 13. Case 2, d is 20, d is 5. So again, we write x squared, y squared. We divide both sides by 5 squared. It will be 30 squared, 13 squared, which will be 169. If we want to check that it is sum of them equals 169, what cases do we have? So without lots of generality, suppose that, for example, one of them is greater than the other one. So it will be greater than 84. Yes. So you should consider 100 for these, 121, 144. We need to only consider these cases. So if it is 100, it is 69. And if it is 1 to 1, then it is what? It's 8. Let's subtract. It's 48. So it is bad. It is bad. It's 4, it is 5, 20. So it's good. So in this case, x, y, and z equals. One of them is 5, but here we have 5 times 5. The other one 5 times 12. And the other one 5 times 13. So we have another answer when d is 5. Let's consider the last case when d is 1. So here we say what? We say z equals r squared plus s squared. And y was what? X was r squared minus s squared. And y is what? 2rs. And we know GCD of r and s are 1. And r and s are not equal mod 2. So here we know z is 65. 65 equals r squared plus s squared. Without loss of generality, we can consider r is greater than s because x is this. So here, because it is greater than this, you say, okay, it can be 25. No, it must be greater than 32. So 36. If it is 36 or if it is 49 or 64. For 64, 1, it's okay. 49, then we have what? We have 16. 59, 65 for 36. If we consider 15 minus 6, 9. 5 minus 3, 2. This case is bad. Now, if we consider this one, so R is 7, S is what? S is 4. So x is what? R squared minus s squared. 49 minus 16. It will be 3, 3. And y is what? 2rs. 4, 2 times 4, 8, 8 times is 56. So one other answer that we found is x 33, 56, and z is 65. Another answer we found. So if we consider this one, r will be 8, s will be 1, so x equals r squared minus s squared, 63, and y equals 2rs, which is 16. So here, if I want to write the answer in for this case, it will be 63, 16, and 65. So let's count. How many answers do we have? 1 here, 2 here, 3 here, 4 here. So the answer of this problem equals 4. SMO 2020 senior section first round, problem number 23. There are 6 couples, each comprising a husband and a wife. Find the number of ways to divide the 6 couples into 3 teams, such that each team has exactly 4 members and that the husband and the wife from the same couple are in different teams. Okay, so suppose that we have, for example, M1 man, first woman, the first couple. 2 M6 W6. Now we have 3 teams, 1 team, 2 teams, 3 teams. They don't have name. So because the teams don't have name, we can, without loss of generality, suppose that M1 is here and MW1 is not here, so it is here. Without loss of generality, it is here. Now we can say they have name because it is for first man, this is for second woman, and here we don't have first man and first woman. Now there are different teams, so here you should place 4 people here. Here we have 5 couples, so we should select, say 5, choose 4. Select 4 couples from these 5 couples and say, okay, from each of them you select man or woman for this part. 2 raised to the power of 4. So without loss of generality, suppose it's M2, M3, M4, M5. Now M6 and W6, one of them here, one of them here. So you say M6 W6 or W6 M6. For M6 W6, and for example, without loss of generality, you consider M6 W6 here. Now you have 2 places for here, 2 places for here. You select, for example, 2, we have M2, M3, M4, M5. W2 to W5 are left. So you say 4 choose 2 for this part and 2 choose 2 for this part. If we calculate this, 5 choose 4 is 5 times 16 times 2 times 4 choose to 6. It will be 80. 80 times 2, 160 times 6, 36, 9. So the answer is equal to 960. SMO 2020 senior section first round, problem number 24. The digit sum of a number, say 987, is the sum of its digit. 9 plus 8 plus 7, which is 17 plus 7, 24. Let A be the digit sum of this number, 2020 to the power of 2021. And let B be the digit sum of A. Find the digit sum of B. So here is what it says. Okay, the first number is 2020 to the power of 2021. And we consider the digit, sum of digits we reach E. And then again we consider sum of digit, we reach B, then sum of digit of B. So we do it again and we want that C is what? So at first let's consider it's this number mod 9 is what? So let me write with black. 2020 to the power of 2021 mod 9. If we consider this number, if sum of the digits of 2020 is 4, it will be 4 2021. And if we consider 4 to the power of 3 is good, you can use this, or you can, okay, let's try. Or also you can say 2 to the power of 40, 42, 2 to the power of 3 is -1, you can use this. But here we say, okay, it's 4 to the power of 3, then it's 6, 22, 7, 11, 3 times 4 squared. So it's 64. 64 is 1. So it will be 4 squared and it will be 16. Mod 9 is 7. Now we've calculated this, that mod 9 is 7. And if you consider some of the digits, always A is also mod 9 is 7, B and C, all of them mod 9 is 7. Because A is sum of the digits. We know sum of the digits of a number is congruent to the number mod 9. Also for mod 3, mod 9, they are same. For mod 11, 13, 7, 25, for some numbers, you have some things that you should learn, the formulas. If you have any problem of this relationship, as I said, feel free to send message to my WhatsApp number in the description in the comments. Now here, we say, okay, this number, we can get rid of 0. If we, let's consider f of something, f of, for example, x is sum of, for example, the digits of x. So if I consider f of this, f of 2020 to the power of 2021, you say, okay, this 0 is useless, you can write this. And we know 2020, 202 to the power of 2021 is less than 1. I want to find the number of digits is at most what? 2021, it will be 10 to the power of 33606. So we can say what? It is less than this, so the number of its digit is at most 60, 63. So it is at most, if all digits are 9, 9 times 60, 63. Because it is the first 60, 64 digit number, so it is less than this, so it has at most 60, 63 digits. If all of them are 9, so f of that is at most 9 times 3, 27. We have 2. 9 times 6, 54. We have 2, 56, 5. And it will be this. So here we've concluded what? A is at most this. 5, 4, 5, 6, 7. If all of these digits are 9, we want to see B is at most what? 1, 2, 3, 4, 5, 5 digits. And we know it's impossible. 5 times 9. But it is at most this. All of them are 9. So A is 2, 4, 5, at most 5 digit number. If all the digits are 9, then it will be 45. Now here, B is at most what? It has 2 digit number. We know this one is at most 4. And 1 digit is at most 9 because it's 2 digit number B. So see sum of its digit. It is at most 4. It is at most 9. And we know it's impossible exactly the case. You can say strictly less than, but we don't need that. It's 13. C is at most 13. We know what? We know C mod 9 because of this is 7. So here, the only possible case for C is that C equals 7. So the answer of this problem is equal to 7. SMO 2020 senior section first round problem number 25. 40 equals 2 times 2 times 2 times 5 is a positive divisor of 1440. That is a product of 4 prime numbers. 48 is 2 times 2 times 2 times 2 times 3. It's 16 times 3 is a positive divisor of 1440. That is a product of 5 prime numbers. 1, 2, 3, 4, 5. Find the sum of all the positive divisors of 1440 that are products of an odd number of prime numbers. For solving this problem, we should know sum of divisors of a number. And it's so much useful. Also in summer camps of USA, promise for 2022, if you wanted to solve one problem, you need to use that. It is what at first you should prime factorize this number. Each 0 is 2, 5, and it is 12 squared. So here we have 2 squared to the power of 2 is 2, 4, 2, 5. So it will be 2, 5, 3 squared times 5. If you prime factorize, it will be this. If you want to consider sum of all positive divisors, it will be 2 squared plus 2 cubed plus 2 to the power of 4 plus 2 to the power of 5, 1 plus 3 squared, 1 plus 5. Because each divisor you can create, for example, 2 squared times 1 times 5. All of the 1440 you multiply these three terms. The divisor 1, you multiply these three terms. You should know the formula for sum of positive divisors. You should know formula for product of positive divisors, number of positive divisors. If you had any question about them, as I said, feel free to send message to my WhatsApp number in the description and comment. So let's solve this here, but the problem wants some of them that are product of an odd number of prime numbers. So here, for example, 2 cubed, we can select, for example, 2 cubed here, and for example, 3 squared and 1 here. So 2 prime, 3 prime, it will be 5. So if I want to consider different cases, I select from here odd. The power is odd. The sum of them must be even, sum of the powers. Odd, odd, odd is one case. Odd, even, even. It will be odd, even. And the last case is odd, even, odd. Let me check it. Yes, even, odd. So you have one odd or three odds, so that some of them be odd. So the first one, odd, odd, odd. You should say, okay, 1 plus, no, 1, no, because the power must be odd. 2 to the power of 1 plus 2 cubed plus 2 to the power of 5 times. Here, odd, it will be 3. Here, odd, it will be 5. Plus. Now it was first case. Second case, odd again. We say 2 plus 2 cubed plus 2 to the power of 5. Even. So it will be 1 plus 3 squared and 1 here. So we've calculated the first two cases. The third case, even. 1 plus 2 squared plus 2 to the power of 4. Here, odd, it will be 3. Here, even, it will be 1. Plus, even, odd. It will be 1 plus 2 squared plus 2 to the power of 4. Even, it will be 1 plus 3 squared. Odd, it will be 5. Now, let's calculate. Here it is what? It is 32. Here it is what? It is 8. So it will be what? 42. Here it will be what? It will be 42. Here it will be what? 16 plus 4, 20, 21. Here it will be what? 21. If we factor from 42 here, it will be 5 times 3, 15, plus 9 plus 1, 10, plus 21 times 3 here, plus 9 plus 1, 10, 10 plus 5, 10 times 5, 50. Now, if we consider, it will be what? It will be 25. 5 times this, it will be 210 times 5 plus. It is what? It is, or you can say, okay, if 25 times this is 63 plus 0, 5, 105. Okay, so here if we calculate, it will be 0, 5, okay, 10, 50. Now it will be 63 plus 0, 10, 1, 210. So the answer of this problem equals 2163. Also, I released the solutions of other years of SMO for open section, junior section, senior section. Many of them for the first time. You can use them. And also I will release the other years, the other rounds, round 2 of SMO. Also I will release USA, AME, AMC for USA Mathematical Olympiad, BMO for British Mathematical Olympiad. And if you want to learn how to solve problem logically, how to solve hard problems and other things, any question, what are the 50 important formulas in geometry, as I said before, feel free to send message to my WhatsApp number in the description and comments.